Hey guys, welcome to 1.3. We are covering day 1 video today. So before we start, let's take a look at your warm-up. I'm going to give you guys a few moments to do your warm-up, and then we will go over the answers together. Make sure you take a picture of this snippet along with the answer key for you to turn in for your warm-up grade. All right? Question says, determine if the sequence is arithmetic. If so, find the common difference and the 52nd term, the explicit formula, and the recursive formula. So there's a lot of things you need to do. Number 1, determine if it's arithmetic. Number 2, find the difference. Number 3, find the 52nd term. Number 4, write the explicit formula. And number 5, write the recursive formula. Okay? So let's take a look at this problem. How do we know if they are arithmetic? Well, you can take the second term, okay, right here. So negative 27 minus negative 37, that gives you 10. Negative 17 minus negative 27 gives you 10. Negative 7 minus negative 17, that also gives you 10. So whenever you take the 1 minus the 1 before it, we all got 10. And since these are the same, that tells you that's a common difference. So the answer to number 1 is yes. Number 2, find the common difference. So D is equal to 10. Make sure you write D or I will count it wrong. Okay? You always need to label. Number 3, find the 52nd term. Whenever you have to find an exact term, you want to use the explicit formula, and the formula for that is a sub 1 plus d n minus 1. So we're going to substitute 52nd for n. So a sub 52, because that's what I'm trying to find. First term is negative 37 plus your d, which is 10, and 52 minus 1. I'm trying to find out what this number is in the 52nd place. So we're going to type that in the calculator just like you see it. Negative 37 plus 10 parentheses 52 minus 1. Okay. So the 52nd placement is 479. Oh, I'm so sorry. 473. Okay. So if I keep going until I get to my 52nd term, that number is going to be 473. Number 4, write the explicit formula, a sub n. That means the formula, I need to put an n because it's going to work every time. First term plus your d n minus 1. Okay. Number 5, find the recursive formula. Here's your first term, here's your d. So a sub n equals a sub n minus 1. Raise it a little bit to the 10th. And the first term is negative 37. And there you have your warm-up. So today's assignment, we are doing an arithmetic sequence. All this up here has been an arithmetic sequence. I'm sorry, we're doing series. Okay? So everything up here has been a sequence. In a series, that just means what do I have as a group. In a sequence, it keeps going and it continues and continues until you look for something. In a series, it has a beginning and an end. So today's goal, you're going to identify the difference in a series and a sequence. Solve problems using arithmetic series. Hence the word, series. Okay? All right. So long time ago, there's a guy named Carl who discovered a way to add integers from 1 to 100 in seconds. Everyone in class was asked to add the integers from 1 to 100 as punishment for misbehavior. In a matter of seconds, Gauss had the answer. It is said that Gauss wrote nothing but the answer of 5,050 on his slate, doing all the work in his head. Imagine the reactions of his teacher. So he's going 1 plus 2 plus 3 plus 4 plus 5, ... Okay, all the way to 100. So as you can see, this is a series. I have a beginning and I have an end. It doesn't ... continue on forever. So how did he find it so quickly? So this is what Gauss did. This is what he noticed. All right. Suppose S of 100 is 1 plus 2 plus 3 plus 4 all the way to 100. Well, he also went backward. He rewrote the series backward, okay? Then he added the two equations together. 1 plus 100, 2 plus 99, 3 plus 98, 4 plus 97, and so forth. The right side of the equation of 100 terms, each one equal 101, as you can see, and so he multiplied them together. That's the formula that Gauss came up with. This we're going to use to help us come up with a formula. All right? So, here are your notes. An arithmetic series is the sum, that means I'm adding, of a sequence in each term is computed from the previous one by adding or subtracting a constant. So basically a sequence in which each term is computed by adding the previous one or by adding or subtracting a constant. There are three methods you are going to learn. Number one, you just add all the list of numbers. This is the easiest one, but for some reason students forget about this. They forget, but that's okay. Number two, you have a formula. You can write it like this, or you can write it like this. Up to you. The third way is called a summation notation, and you use what's called that letter in Greek is called a sigma, okay? So you put your starting term here, you put your ending term there, and then you use a rule. And usually this is an explicit formula. In arithmetic, it's A1 plus DN minus 1. And you're going to use that to let the calculator do all the work for you. So for example, let's look at the very first one, okay? So we're going to look at adding the list of numbers. Remember, a series has a beginning and an end. So let's look at example 1. I'm starting with an 8 and I'm ending with an 18. Question says, to evaluate an arithmetic series, you add the given term in the sequence. This tells you it's already arithmetic. I'm increasing by 2. But I start here at 8 and I end at 18. So how would you do that problem? All you have to do is on your calculator, add it together, just like that. And you write S sub n equal, if you want to know what n is, you can. 1, 2, 3, 4, 5, 6. You can put S sub 6, but I'm just going to put S sub n. And you just add that to your calculator, just like so. 8 plus 10 plus 12 plus 14 plus 16 plus 18. Okay? So when I add all this together, I get 78. So that's step 1. That's one way to do it. Number 2, you're going to add all these guys together. Okay, you could write it like that if you want. So you have 28 plus 37 plus 46 plus 55 plus 64. S sub n, 230. But let's see if they add up. So you're adding by 9 every time. 28 plus 9 plus 9 plus 9 plus 9. Okay, see how it's arithmetic? Same thing, 6 plus 14 plus 22 plus 30. 6 plus 14 plus 22 plus 30. I'm increasing by 8 every time. So S sub n is equal to 72. Okay. 44 plus 54 plus 64 plus 74 plus 84 plus 94. Notice there's no dot, dot, dot. And you just add that to your calculator. 44 plus 54 plus 64 plus 74 plus 84 plus 94. I'm increasing by 1, by 10. So that summation is 414. And that's one way you can add an arithmetic series. Okay, just like so. All right. Now, what if your series is too long? You can add it together. And if that method you want to use is this method right here, okay? There's actually a formula. And there's your formula. This is called the sum of a finite arithmetic series formula. What does S sub n mean? That's the sum of a series. The word sum just means add. I'm adding all the numbers together. N is your number of terms. A sub 1 is your first term. A sub n is your last term. Okay? So half of the number of terms, because Gauss went 1 to 100, then he went 100 to 1, so halfway, you add the first and the last term together. All right. So for example, find the sum of the positive integers from 1 to 100 inclusive. So the formula is S sub n equals n divided by 2, first term plus your last term. I'm starting with 1, I'm ending in 100. See that number? How many terms are there? It's 100 divided by 2. And that's how Gauss got his solution. So S sub n equals 550. I'm so sorry, 5,050. Ooh, it's been a long day. All right, this is example 3. Evaluate, that basically, go find me an answer. Evaluate each arithmetic series described. So let's take a look if we can use that formula. Do you have an n? Do you have a first term? Do you have a third term? So the three things that you need to have to work this problem is an n, first term, and your last term. Okay? So here we go. I have all of them. So I'm going to use that formula. S sub n divided by 2, first term plus your last term. And you can just type into your calculator. Watch. 10 divided by 2, parentheses, like that. 9 plus 45. Oops, I forgot something. 5 parentheses, 9 plus 45. There we go. 270. So if I start at 9 and keep adding up to 10 numbers, so that is 9 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 45. And I just keep adding these numbers. Don't know what D is. If I just keep adding these numbers, I'm going to get 270. Just like that. Part B. S sub n equals 10 divided by 2. First term is 1. Last term is 100. I'm going to let the calculator do the work for me. 10 divided by 2 times. Okay. First term is 1. Last term is 100. It's come out to be 505. All right. Let's look at C. S sub n equals 20 divided by 2. N divided by 2. First term is negative 10. Last term is 150. So 20 divided by 2, okay, times, this calculator doesn't type the one before it, kind of weird, negative 10 plus 150, just like that, 1,400, 1,400. All right, method 3, summation notation. We're going to follow that for tomorrow. So today, just do your day 1 practice. Okay, thank you guys.